Hello everybody, starting from this video, we're going to learn chapter 5 and 6. And keep in mind that we don't cover everything from chapter 5 and 6. We only cover certain sections that is highly related to the business and economic world. So in chapter 5, we're going to learn the discrete probability distribution. And in chapter 6, we're going to focus on the continual probability distribution. When you read the textbook, you will find under the chapter 5, we actually have many different kind of discrete probability distribution. However, we only focus on the general discrete probability distribution, binomial probability distribution, not other discrete probability distribution. In chapter 6, we only focus on the continual probability distribution called the normal probability distribution, the exponential probability distribution won't be covered. So therefore, when you read the textbook, please read selectively. And also, we will finish chapter 5 and 6 first, and then we will go back to chapter 4 after we finish 5 and 6. The reason is because chapter 4 is the very basic probability that you can use in the business world. And in chapter 4, we're going to focus on the Bayesian theory. So that is not a lot of information to cover, but we will wait after we finish chapter 5 and 6. So in this first video, I will let you know what we're going to cover from chapter 5 and 6. And so make sure you are reading certain sections so you don't have to read the full chapters. So in chapter 5, what we will look at is what is called the random variable. And then we're going to look at the expected value and the variance. And then we're going to look at the binomial distribution. And as I said, in chapter 6, we only cover the normal part distribution. Therefore, when you look at this week's learning slides, we only have one slide, but it covers both chapters. The reason is because we only select the important section to cover. And for other sections, I encourage you to read it, but it's not required. So first, let's look at a random variable. What is a random variable? A random variable is a numerical description of the outcome of an experiment. So again, similarly like what we learned before, I don't really want you to spend a lot of time to memorize the definition. Instead, I want you to understand the definition, what it really means, because you need to use it to solve business world problems. Nobody can ask you for the definition. Instead, they want you to properly use the method. So the key word in this definition is numeric description. So think about in chapter 1, we defined the definition for data. So the data can be figures and facts. So it doesn't have to be numbers. However, when we move on to looking at a random variable, it has to be a number. So therefore, it's a numeric description of an outcome of an experiment. So the random variable also involve an experiment. If you say eye color, it doesn't consider as a random variable because it doesn't involve an experiment. However, if you describe eye color as I'm randomly go outside on the street, I randomly look at a person and what the color of that person's eye color, that will become a random variable because that involves experiment. You go outside to pick a person to look at the eye color, so that become an experiment. And so if you only see the eye color is a white, yellow, blue, it's still not considered as a random variable unless you label it. If the eye color is black and the value equal to 1, if the eye color is blue equal to 2, is green equal to 3, etc. You give the numeric value to that outcome, and then the eye color of a person you picked on the street become a random variable. So the two keywords, numeric description, and it's definitely coming out of an experiment. Okay, so this is called random variable. So generally speaking, we have two different kinds of random variable. So one is called a discrete random variable. So discrete random variable may assume either a finite number of or an infinite sequence of the values. And so I will give you a few examples pretty soon. And the second type of random variable is called a continual random variable. A continual random variable may assume any numeric value in an interval or a collection of the interval. And so first I will talk about the discrete random variable because in chapter 5 we are focusing on the discrete random variables distribution. And in chapter 6 we're actually going to focus on the distribution for continual random variable. So look at, I give you two examples. One is for finite discrete random variable, and another is for infinite discrete random variable. So first, x is the random variable. X is defined as the number of the TV sold at a store in a day, where x can take on 5 values, 0, 1, 2, 3, 4. So in this case, x is a finite discrete random variable. First of all, x is a random variable, right? It's coming out of experiment. That is the TV sold in a day. So one day, how many TV they can sell. And the second is a numeric. So it only can take the value 0, 1, 2, 3, 4. So it's a numeric. So why this is a finite discrete random variable? Because for this discrete random variable, we can find the lower and upper limits. So the lower limit is 0 and upper limit is 4. So therefore, this is a finite discrete random variable. And the next example is the example as an infinite discrete random variable. X is defined as the number of the customers arriving a day, where X can take on the value 0, 1, 2 to any positive infinite number. So in this case, X still is a random variable, right? Because it is a go through experiment. So that is a number of customers coming in one day. So in one day, you observe how many customers show up. And the second is numeric. It can take any non-negative integer, 0, 1, 2, 3, etc. And so this one is infinite because this random variable doesn't have upper boundary. So in the situation that the discrete random variable has no lower limit or upper limit, or don't have both lower and upper limit, we are having an infinite discrete random variable. So can you give me more example in your daily life? Can you find the finite discrete random variable? Can you find an infinite discrete random variable? Okay, let me give you a few examples. So for instance, you are taking a class this semester, right? So think about the number. You randomly select a semester, the number of the class you take, the number of the classes you take in one semester. First of all, it is a random variable, right? Because first, it is to go through experiment. It is you look at one semester, how many class you take. You pick any one of the semester. So it's a kind of experiment. And the second, this is a discrete because the value you were taken is non-negative integer. So the question is this a finite or infinite? So the answer is it is finite because based on the university policies, no student should take more than 18 credit hours, which is equivalent to almost 6 classes. And so you have lower limit, which is 0 classes, and upper limit is 6 classes. So this is a finite discrete random variable. How about infinite discrete random variable? Any thoughts? Okay. So how about the number of the email you can receive in an hour? So if you are so first of all, this experiment I didn't see on the email you got. So that will not consider as experiment because you are not well defined what kind of experiment you are doing. I'm talking about in an hour how many email you can receive. So this is a random variable is go through experiment, and also the second is because the number itself is integer, is not any real values. So therefore it's a discrete. So why is it infinite? Because we do have lower limit, which is zero email, but we don't have any upper limit. You really can get as many email as you can within an hour, depending on how popular you are or how many scam email you got in that 1 hour too. So it will be 0, 1, 2 to positive infinite in that 1 hour. So therefore, this random variable called the number of email you got within an hour will be considered as an infinite discrete random variable. Okay, so these are the two actual examples. So I want to show you more. So they are all considered as random variables, but I also give you one is continual random variables. So for instance, you want to know the family size. So it is not our random variable yet because it has to go through an experiment, has to be numeric. So family size, you didn't define how to quantify it. Therefore, we're going to translate this question to a random variable x. So that will be defined as the number of dependents reported on the tax return. So this is a discrete random variable. And so the second example, distance from home to store. So it can be any positive real value. It doesn't have to be integer. So it is x is the random variable. It's defined as the distance in miles from home to store. Therefore, this is a continual random variable. And the last one, on dog or cat. So this is just a question, but it's not random variable yet. Therefore, we're going to define our random variable. So x equal to 1 if you own no pets, x equal to 2 if you own dogs only, x equal to 3 if you own cats only, x equal to 4 if you own dogs and cats. So obviously, in this case, it is a random variable and it is discrete because x only take 1, 2, 3, 4 integer values. So this is discrete. And also pay attention, this is a finite discrete random variable. Why? Because some students say, no, I can have as many paths as I can. It's infinite, right? But pay attention on what this how this random variable defined. So this random variable is not defined as how many paths you have. It is what kind of paths you have. You either have no paths, or only have dog, or only have cat, or you have both cats and a dog. So you only have these 4 scenarios to choose from. Therefore, this actually is a finite discrete random variable. So this x can only take 4 possible values, 1, 2, 3, and 4. So this is a little bit confusing, but if you carefully evaluate this random variable, you understand that this is not asking you how many paths you have. Instead, this is asking what kind of paths you have. So this is how we define random variable. And after you understand the random variable, and then we can start to look at what we are focusing on from chapter 5, discrete probability distribution. So the probability distribution for a random variable describes how probability are distributed over the value of the random variable. Like I said, random variable, they are random. Even it's random, people still want to see the pattern so that we can use it to do the forecasting. Therefore, we're developing this statistic called the probability distribution. It is like a map to mapping the routine of this random variable, where they go, what's the chance they will go there, what's the chance they will go here. So this is the probability is used to describe how this random variable going to move. So we can describe a discrete probability distribution with a table, graph, or formula. So the first in this video, we're going to focus on table and graph. And in next video, we're going to look at a binomial distribution. So that will be considered using a formula to describe the discrete probability distribution. So two types of discrete probability distribution will be introduced in chapter 5. The first type, as I mentioned, using the rules of assigning probability to experimental outcome to determine the probability for each value of the random variable. Don't worry, I will show you an example to let you know how that works. Basically, this method is like we're developing frequency distribution we learned in chapter 2. We're developing the frequency distribution for my random variable. And so the second type, we use a special mathematical formula to compute the probability for each value of the random variable. So the second method is we literally characterize certain discrete probability distribution that we actually can use a complicated mathematical formula to summarizing those random variables. The good thing for this method is that we have already mature statistic formula to allow us to get the probability very quickly. However, the difficult part for the second type is that you have to be able to identify the random variable is belonging to that mathematical formula. So that's what we're going to look at in the next video, the binomial distribution that is belonging to the second type. So let's introducing the characteristic for the probability distribution. So the probability distribution is defined by the probability function called fx. So the f stands for function. So the function of x. So the x is a random variable. So that provides probability for each value of the random variable value and the required condition. So this is important, I want you to remember. In order to define your own discrete probability distribution, you have to check these two properties. So fx is the probability. So the probability for the random value has to be non-negative. So basically, this is a requirement for the probability. You won't have any negative value for the probability, right? So you can see the chance for me to get to win the lottery is negative 20%. What is negative 20% means? Nobody can see that. The reason is because the probability cannot be negative. And so the second property is if you add all the probability for the random value together, you will end up 1. Okay, so those are the two properties has to be satisfied by your discrete probability distribution. And we're going to look at example, and we're going to revisit these two conditions again. So we have three possible methods to assign the probability: classical method, subjective method, relative frequency method. In this class, we focus on relative frequency method. Basically, we are doing experiment and then figure out the relative frequency distribution for the random variable. I'll show you the example. So JSL appliance. So this is about JSL appliance. So they are using the past data on TV sales, and then they create this tablet representation. We also call it frequency distribution, right? So what happened for this owner is they go back the company to look at, okay, for the past 200 days, and how many days they sell nothing, how many days they sell 1 TV, how many days they sell 2 TV, 3 TV, and 4 TV. So that's this distribution. So based on the experiment, they got a frequency for this random variable called the number of the TV can be sold in a day. So this is the called the frequency distribution we learned from chapter 2. And then we're using the method we learned in chapter 2, convert the frequency distribution to relative frequency, right? Relative frequency, basically we're using each frequency divided by the sample size, and then we got the relative frequency. Here we don't call it a relative frequency anymore. We actually call it a probability. So after I calculate the relative frequency and I list in one more new column and I relist my value for the x value. So this last two column is called the probability distribution for the random variable x. So the x is the number of TV can be sold in a day. So how we read this table? So based on the data we collected, we understand that we have 40% chance sell nothing. We have 25% chance to sell 1 TV and a 10% chance to sell 4 TV sets. So this is our discrete probability distribution, okay? So let's go back very quickly to look at the property, okay? We're going to look at these two property. So the probability larger than 0 and the sum all probability together equal to 1. We want to examine this probability distribution, whether they satisfy all two properties. First, look at my probabilities. They are all positive. Okay, so the first property checked. And now we look at the second property. If we add all the properties together, will we get 1? The answer is yes, we end up 1. So the second property check as well. So now these two columns we developed, it become the discrete probability distribution for my random variable x. That is the number of TV we can sell in a day. So why getting the probability distribution is so important? Because after you get the probability distribution, you will be able to get the central location and the variability very quickly. So that is what we are introducing. If you have this probability distribution table, this probability distribution, you can using the following formula to calculate the expected value and variance and the standard deviation. So what is expected value? And I want you to take a note. Expected value, sometimes we also call it as mean, but actually it is the weighted mean, but also it is weighted average as well. So basically this is the one we use to measure the central location for my random variable. So how can we calculate it? So the expected value or mean of the random variable is a measure of its central location. And so pay attention on the notation. So EX stands for expected value of X equal to mu. Remember, this is the population mean. For probability distribution, although the data we saw previously is collected from sample 200 days, but we believe the probability distribution we find based on the sample data is representing the population as well. Therefore, what we are calculating here is the population mean, and it is equal to the summation of x times fx. So the random variable's value multiplied by its corresponding probability. So let me give you an example and to help you to understand how to expanding this formula. Because even we are using the Excel formula, we still need to figure out how this expansion, how this summation works. Okay, so let's see. In this case, we have the random variable x have 4 possible value. Okay, x1, x2, x3, and x4. We have 4 possible value for x. And so to help you to calculate the value of x for this case, and then it will equal to x1 times the probability of x1, and then plus x2 and the probability of fx2, and the plus x3, the probability of fx3, and plus x4, the probability of fx4. So that is how we expanding this formula, okay? And then what I want to point out here is the expected value is the weighted average of the value the random variable may assume, and the weights are the probability. So you need to remember this. So the fx1, fx2, fx3, fx4 here, they are actually is the weight to weight for each outcome, x1, x2, x3, x4, who is more important. Because if the corresponding x has random value have relatively larger probability, that means they're important. We should give them higher weight. Therefore, we multiply by its probability. So let's look at the example before, first, and then we'll come back for the variance. So we look at the SL appliance again. So in this case, the x have 4 possible outcomes, 0, 1, 2, 3, 4, and the corresponding fx here. So based on the formula, and so this expected value of x, right, will equal to x times fx. We got got 0, right? Because 0. So 1 times, then 1 times 0.25 equal to 0.25, 2 times 0.2 equal to 0.4, 3 times 0.05 equal to 0.15, 4 times 0.10 equal to 0.40. And then after you get the product of these two components, and then you add them together, then you got 1.2. So on average or expected value, and so this SL appliance can sell 2.1 TV sets. And so why this expected value is so important? If you're do your own investment, sometimes you can hear what is the expected return of this stock. So what does that mean? So actually we are treating the stock price as a random variable, and then we calculate their weighted mean, and that's how we figure out their expected return. Okay, what is your expected return? So this is the value you will use to measure the central location of your random variable. How about the variability? Remember in chapter 3 we emphasized that we also need to measure the variability of the data. We also need to know the variability of the distribution. So this is the math, the statistic we're going to calculate to measure the variability is called variance. Everybody know variance. So the variance for the random variable is use VARX to representing the variance of x, random variable x. And so this value is equal to the population variance. So it is the product of x minus mu, so the observation minus central location square times the probability. So for each pair, you can for each observation you do this calculation, and then add all the product together. That's gonna give you the variance. And so let me show you the examples. Let's see, x have 4 possible outcomes: x1, x2, x3, and x4. So how are you gonna expand this formula? So this formula will equal to, okay, will become x1 minus mu. You still need to calculate expected value first, and square, and fx1, so x1's probability, and then plus x2 minus mu square and the fx2, and then plus x3 minus mu square and fx3, and then plus x4 minus mu square and then fx4. So this is how we calculate if this random variable only have 4 possible outcomes, x1, x2, x3, and x4. But you can see how you're going to expand in this summation. It's important because even we use Excel, we still need to know how to extend it because you have to know what you need to put into your formula, okay? And so the variance is the weighted average of the square deviation of the random variable from its mean. Again, the fx here is a weight. Fx is a weight. And so then after you got variance, you take the positive square root, and then you will be able to receive the standard deviation. So in our next video, you will be able to learn how to use Excel to calculate it. But here, we have to explain what is Excel trying to calculate, okay? So now we look at SL appliance again. So we already know the expected value is 1.2. So this is my mu, okay? Now we're going to start to calculate my variance. So based on the formula, what we're going to do is first we're going to calculate x minus mu, right? So mu equal to 1.2 in the previous slides we calculated. So then we calculate the x minus mu for each random variable's value, each random value. So then that's my second column. And now we're going to square it because based on the original formula, so these differences has to be squared. And now I list all my fx, so that's my probability corresponding to each random value. And then based on the formula, I need to use x minus mu squared times fx. So therefore, the value in the third column will be used to multiply by the value in the fourth column. And then the result is ending in my last column. And then we're going to perform the summation. Basically, we're going to sum all those values together. And then we will receive 1.66. So this is the variance for this case. And then I take a positive square root, and I will be able to receive my standard deviation. So that is how you calculate the expected value, variance, standard deviation. And so, of course, we do have Excel. We have a very quick summation formula we can use to help us to calculate expected value, variance, standard deviation for the discrete random variable. Therefore, I want you to log in D2L, download the file under this week's attendance check. So there is computer skill 3, and then there is a data file. Make sure you download it, and then you watch next video. You will be able to learn how to use Excel to calculate the expected value, variance, standard deviation. So everything we're gonna do in the Excel part is conditional on you already understand those summation forms. So the summation operator, how that works, okay? In next video, we're gonna look at discrete power distribution. Special discrete power distribution is called a binomial distribution. And so before we move on to there, so make sure you know how to use Excel to calculate the expected value, variance, and the standard deviation.